Hello world, it's Siraj, and I've built an app called VectorFunnel. What it is it's an app for sales and marketing teams to automatically score their leads using deep learning technology. Let me give you a quick demo of what I mean. The first step in my app, VectorFunnel, is to sign in with Google Authentication. That means your Gmail account. Once I've signed in as a user for that Gmail account, I'll be redirected back to my app. Then, once I've authenticated, I can then score my leads automatically. So the first step for me is to pay 100 USD. Now this is a test card that I'll type in using the Stripe API. And once I've typed in that test card, it's gonna ask me to upload my leads. So let me show you a sample copy of leads that I have here. These are clients for my fictional company, but it's an example data set for this demo. And what it is it's a bunch of people that are my clients and their company and a bunch of different features that describe their behavior. So have they purchased from us before? Are they a community member? Where are they located? And then we have the target variable. This is what we're trying to predict, right? So did this person convert or not? And we've represented it as a binary class, 0 or 1. Now we have a history of sales, assuming that we are a user that's using this app, right? We have a history of clients that have either bought our product or not. And we can show that in our client CSV file. And so I've labeled it right here as a binary classification example. And so what our app is going to do is it's going to take this data and it's going to perform machine learning on this data and then give each client a score from 0 to 100. Let me show you what I mean to see how likely they would be to buy our product. Now our machine learning model is training in the cloud, and when it's done, it's going to show us one very simple visualization I built using d3.js that segments the customer base into those that had a higher than 60 score and then those that had a lower than 60 score. Now 60 is the lead score, right? And then once we're done, we can download this data, and what it does is it appends that existing CSV with the automated lead scores that were predicted using our machine learning model. And once we have that, the client can then see those scores that are in this new column right here called score on a scale of 0 to 100. And based on that, they can decide whether or not to allocate their time and energy and resources towards that client or not, right? It depends whether or not this person had a high score or not. If they did, it's time to call them. It's time to, email them, keep trying to nudge them to make a sale. And right now, the way to do this, a lot of people is they do this manually. They try to assess the quality of a client, but we can automate this. And that's the benefit of machine learning technology. So that's the demo for this video, and there are a lot of components to build to get there. But the three main ones that I want you to remember are React, which is a JavaScript library. That's right, I'm going to be talking about React. And Node.js, which is another JavaScript library. So React is for the front end, Node is for the back end, and then Postgre, which is the database, the SQL database. And on top of all of that is our AI layer, that is Tensorflow.js, a JavaScript library for machine learning models. Now we're going to use these tools together to build this web app, and I'm going to show you the process that I've used to build this web app, and hopefully by the end of this tutorial, you will have a high-level overview of how to put different components together to be able to create some sort of profitable service that can serve people in the marketing arena. Now, this is just one example, but it's a very useful thought exercise for you to do. Even if you're not interested in marketing, it's still a useful thought exercise because this is how we actually serve AI to people, right? AI is indeed the new electricity, but unless we wrap it with that proper infrastructure of Node, React, right? These client-side and server-side components, no one's gonna be able to use it. Training and testing a model is a lot of fun, but we've got to wrap that in the infrastructure to then serve to people, and that's the point of this video, to show you that entire pipeline of how these tools are put together to serve users. Now, it's a 10-step process that I'm going to go through, all right? So let me start off with market research. So how can AI help marketing teams? This is a question we have to ask ourselves. And I found this nice little infographic that says the AI-empowered marketer looks for a precise formula, and that formula is personalization. We want to personalize our products. We want to personalize our content. We want to personalize our outreach to each individual customer. Why? Because it increases conversions. Now, what does this personalization actually actualize as? Well, it turns out that if we look at the applications for AI in marketing, there are quite a lot. There's ad targeting, there's predictive analytics, there's web app personalization, there's dynamic content emails. So there's quite a lot that we could do for marketing teams here. But one in particular that sticks out to me is lead scoring. Now, for this example, I feel particularly passionate about lead scoring because I don't know, I'm passionate about this one. So I will pick this one, lead scoring, to be my application. Now, what is lead scoring? Lead scoring is taking a bunch of leads, these are clients that are in the pipeline of either a sales or marketing team or both, and scoring them based on how likely they would be to buy our product or service or whatever it is we're selling. Now, how does basic lead scoring work? Well, there's a lot of rule-based systems out there where we go through the data and we see, did this person say download a case study? Did they visit our pricing page? Did this person read our email? And all of these are different points that we could add to their score. And at the end, we concatenate all of those points and that is their score. But what's better than rule-based systems? Machine learning, exactly. Machine learning is better. It gives you a more accurate lead score. That's the point. Now, the next step is to see who our competitors are. And I found two that I think really stick out. One is called InsideSales.com, and the other one is called Infer. Now, both of these are pretty big corporations, and they offer quite a lot. Not just lead scoring, but a full suite of tools, whether it's visualization, ways to connect with people, engagement options, things like that. So they're pretty heavy apps. The problem with these apps is that they require a user or potential client to request a demo. So there's everything is on demand these days. People want things really fast. And if we're able to offer something faster than them, that is a plus to our application. Now, how else are we going to compete with these big giants? Well, we can provide better lead scores by using our knowledge of modern AI techniques. It's likely they're not using a deep neural network. Maybe, whatever they have works well enough. Who knows? We'll also offer upfront pricing, so that's a faster pipeline. And we're gonna offer one single feature, that is lead scoring. We're not gonna do everything else, so that offers simplicity. So on these three points, that's how we're going to compete with the rest of the companies out there. Before we do anything, we want to see if people are actually going to buy our product, right? And the way to do that is to design a landing page. And we can do that very easily using MailChimp. And MailChimp lets us do that. And I actually have a great video on how that works. It's called Watch Me Build an AI Startup. In that video, I talk about how to use MailChimp to instantly create a landing page. Definitely check out that video. And it also shows you how to promote that landing page via social media. But the whole point of that is to be able to have at least 10 signups for our landing page. And if we have at least 10, then we know that this is a product that people actually want. And if we put the price there and the product description and people still sign up, we know that they're willing to pay. They're willing to dish out the money, right? And that's what we want. It's market validation. And when it comes to branding for that landing page, use brandmark.io. I said that in my last video. Now, let's get to building a little bit here, right? So how do we start here, right? We know what we want. We want to create an automated lead scoring application. How do we then build that? And the answer is, let's start off with first thinking about what are the bare minimum tools that our app needs that are not specific to our use case? What are the bare minimum tools that are just general as possible? Well, the first is user login sign-up functionality. All apps that serve users need this, especially paid apps. So that's one. The second one is we need some kind of database to store data, right? It's a general thing that web apps need. And the third is for our specific use case. If we think about people who have CSV files, you're not going to upload a CSV from your mobile phone. You're going to drag and drop it from the desktop. So we then need a web-based app to start off with, and then we can offer a mobile-based app. So those are the three base things that we need. We need a web-based app, we need user sign-up and login functionality, and then we need database functionality. Now, normally we would just start building all of this from scratch, but a better way to do that is to search GitHub to see what exists out there as a skeleton repository, as a base repository for us to build off of. And I found one called React Firebase Starter. Look at how many stars this thing has. It has quite a lot of stars. So it's very popular. And it says it's a boilerplate project for creating web apps with React, GraphQL, and Relay. Don't worry if you don't know what those are. Now, in fact, this tech stack is using a lot, right? It's got Material UI, Passport.js, Universal Router. There's a lot of different tools here, Connects, Relay. So don't worry about that. That's what this video is for. I've gone through this complexity for you, so I will explain each of these tools in an easy to understand, hopefully, way. All right, so this is our starting point. That's all you should know. This is our starting app. From this app, we will build everything else. So let's go ahead and download it, right? The first thing we're gonna do is we're gonna download this app. And once we've got it, I'm gonna open it up. And then I'm going to CD into it. All right, so I downloaded that app. That was step 2. Step 3 is to configure our dependencies. Let's see what the tutorial here says to do to start this up. So we've got to do yarn setup. Okay, yarn. Yarn is a package manager for Node.js. It's very similar to NPM, but it's newer. When I type in yarn setup, what it's doing is it's installing all of those dependencies that were listed in that dependency file that was already a part of the app right there. So it's downloading all those dependencies. When it's done downloading those dependencies, then we can go ahead and start our web app by using yarn start. And so it's going to take a while to download these dependencies. Let's wait a bit. Great. Now that it's done downloading those dependencies, we can go ahead and start our app with yarn start. Great. Okay, so now it's running on our local machine. Now, I do want to note that when I first downloaded it, I still had to install Postgre and I still had to install Watchman. And the way to do that is for Watchman, because it's a Node package, you just do yarn add Watchman. There's also Postgre, which Mac has this really easy application right here, which is Postgre 11, and it's a GUI interface. Now, once we have that, we can go ahead and try to sign in, see what happens. Okay, so it says invalid client. And what that means is that we have to configure this application so that it can access our Google credentials, right? So in order to continue with Google, we've got to go into our Google Developer Console, which I have right here. Now, what are we going to do? Well, we're going to create a new app. So I'll create credentials for OAuth, which is the way that we authenticate our user. It's a web application. I'll name it whatever my app is. What is it called? It's called React. Let's call it React Firebase Starter Master 1, and then I'll click Create. It gives me my client ID and my client secret. So let's go ahead and put that in our code, a client ID and a client secret. And it turns out that is in the .env file. So this is the client ID, and this is the client secret. Now, before we go any further and look at the app and try to discern how it's working and what all those tools are, let's take a step back and focus on UI UX design. So we have to try to envision what our app is going to look like. So the basic step here is that we know that we want an index page, and on that index page, we want there to be product information, right? We want to be able to captivate a user to pay for our service. So that's one thing that we want. And what we can do is we can change this base app here, right? This base app has a bunch of boilerplate copy that we can just change the text of, and we can instead make it look like this, which is what I did. I changed the app. I put in features of my technology instead. I changed the copy. I changed the logo to VectorFunnel, and that was my initial landing page for my MVP, the fastest method to prototype, the minimum viable product. That's what we're trying to build. We're trying to go as fast as possible until we can build something that works, and then we iterate, right? That's the mentality, rapid experimentation. So we know we want an index page that allows for Google sign-in and product information. Easy stuff. Then what do we want? Well, we know that once they've signed in, they've authenticated, they've created an account, then we're going to want for them to pay. So how are we going to get them to pay? Well, one service that I like is Stripe. Now, Stripe doesn't work everywhere. Use whatever payment processor you like the most. I like Stripe. So we'll use Stripe for payments. Once they paid, what do we want them to do? Let's think about this. Well, we want them to upload their CSV file. And so we'll use some CSV module of React, I'll explain React in a second, to upload that file. And so once they've uploaded that file, we have data. And now what happens? Now data science happens. Now machine learning happens, right? So we're going to have to pre-process that data, and then we're going to have to apply a machine learning model to that data. And what we're gonna do is we're gonna apply 3 different models: a K nearest neighbor classifier, a deep neural net classifier, and a random forest classifier. And we can build all of these very easily with Tensorflow.js. And we're gonna feed it to all of these models. All 3 of these models will train. Okay, and when they're done, we're gonna try to see which has the best score. Now, the one that has the best score is the one that we're going to use. And that's how inference works. Now, once we've made that inference, we're going to create one more page, and that page is called results. And on the results page, we're going to show those top 10 scores of the top 10 clients that had the highest predicted lead score. We'll also visualize those customers in some way, perhaps customer segmentation into those that had a higher than 60 score and a lower than 60 score, or whatever threshold you want. And lastly, we'll create a button that lets that user, download the CSV with the newly added column of automated client scores, so they can use that. And that's kind of the basic minimum viable product we want for our app. So the index is really easy to modify. The upload page and the results page, those other 2 pages, that's where the logic gets interesting, right? So before we get into that, and we will, let's talk about these tools. Now, as recall that in this repository that I showed you, there are a bunch of tools, and it's not really clear how they all work together, well. So I'm gonna explain that to you, okay? Get ready for this. I'm gonna explain to you how these tools work. So let's start with the back end. The distinction here is front end is user facing, all those pretty elements, and back end, that's where all that heavy logic that has to do with saving data, retrieving data, right? Storing data, manipulating data, all those different algorithms and data structures, that's the back end. And what are we gonna use for our back end? Well, we're gonna use a library for JavaScript called Node.js. Now, Node.js is JavaScript. It's pure, normal, good old modern JavaScript, but it's got some added features. And those added features are input-output. That means writing files, handling network connections, doing a bunch of tasks that are normally suited for some other language like Python or some other backend language like Scala. Node.js does all of this in JavaScript. And the reason this is good is because it means that a developer can build an entire application, both the front end and the back end, in just JavaScript. They don't have to deal with multiple languages. And this is simpler to build. It's all JavaScript. And the way this works, the way Node.js works, is it's really good at handling multiple requests at once. So if you have multiple users trying to access your server, your Node.js server, all at once, rather than having them wait one by one for each of those requests to complete, Node.js allows these requests to be made asynchronously, not synchronously. What does that mean? What that means is that in normal synchronous programming, you call a function, it does something while you wait, so it's processing. And when the function returns, the action's finished and the data is available. But in asynchronous programming, the function, when you call it, it will return immediately. But meanwhile, that operation of what it's computing, it's happening. So the user doesn't have to wait, it's asynchronous. Now, images are great at explaining things, that's why this is video content. Synchronous means one request at a time. Asynchronous means multiple requests simultaneously, okay? Now, the way Node.js does this is by using an architecture, an asynchronous style of programming called the event loop. And what the event loop is it's a program that waits for events and dispatches them when they happen. So requests are going to our Node.js server, and functions are being returned automatically, just as they're called, right? And so, but what's happening is inside of the event loop, the action of these functions, whatever they're doing, it's waiting there to then be applied to whatever intensive operation needs to happen. What that means is that the user doesn't have to wait for some back-end processing to happen to see some element on the front end, right? They don't have to wait for the user's data to be pulled from the database schema for them to be able to see the outline of a user's profile picture, right? So sometimes you'll notice in Facebook or some of these social networks, you'll load up a profile and then at the start it will show the circle, but the for a person's profile picture, but the icon is empty. There's no picture there. That's because it's using asynchronous programming. It's loading that element, even though the function of calling the data hasn't finished yet. That's happening asynchronously using the event loop if they're using Node.js. And then, so that means a user doesn't have to wait. Nobody has to wait. It makes things faster. So multiple requests can hit our Node.js server all at the same time, and it can handle it beautifully. So that was our backend, Node.js. Now let's go to our front end, which is React. So this is an image of how React, Node, and the browser, the user, all work together. So the user is sending data to the React front end, and so is the Node.js server from both the database and from whatever other data structures it's using. Everything, all that data goes into the front end with React. Okay, and then React will send updates back to the user. And the user is actually making the HTTP request to the Node.js server, but it's getting served updates via React. So what is React actually? Well, it's a library, a JavaScript library, whose primary purpose is to deal with the hard problem of state, measuring state. What is state? State keeps track of your app. It keeps track of different events that occur in your application. Did the user click this? Did the user sign up? Did the user do whatever? All of that is part of the state, and the state changes over time, and it changes across different pages of your web app. So you want to keep track of a user's state throughout the web app, whether or not they leave, they come back, they could do a bunch of different actions, but we want to keep that state for whatever web page that we're loading up. And so the idea behind React is we're creating these custom reusable DOM, document object model, objects like buttons and lists and all sorts of things that you would see on the front end, and structuring the flow of data throughout the page from actions taking place to the view being updated. Now, the difference between React and normal JavaScript is that React is declarative, not imperative. So the idea behind declarative is that you're telling the program it should look like this, whereas imperative says you should do this. So with vanilla JS, that's imperative, you're saying whenever someone clicks this button, update this text, right? So whenever someone clicks a button, update some text. And that's saying, here is what you should do. The declarative way of saying this is, it should look like this. Instead of saying whenever a user clicks the button, update the text, say whenever a click happens, set the state to this. And then depending on what the state is, render the text in the browser. So this is much more modular because the state could be many different things, right? And the state keeps track of whether or not a user has done anything. So it's more state-based. And notice that this code looks kind of weird, doesn't it? Because it looks kind of like JavaScript, but it also kind of looks like HTML. Well, it turns out that this is called JSX. And JSX is an extension of JavaScript to look more like XML/and HTML. And so this goes against a lot of the logic from MVC architecture from, say, 5 to 10 years ago, where the idea was to separate your HTML files, your JS files, and the CSS files. In React, all of those things are put together in the same view. So the view is actually handling the processing in terms of the HTML and the JavaScript. And it's this language called JSX. And the biggest difference between JSX and plain JavaScript is the use of, instead of the word class, you use the word class name. And I'll talk more about that when I show you some JSX. But the point is that this is much better for handling the state of the app. And as an interface grows in complexity, it pays dividends to follow this way of handling state. And guess who does this? Facebook does this. They use this internally. This is their tool, React. And they do it for good reason. Now, normally we would manipulate the DOM, the document object model, the page that we're dealing with of our app. We would manipulate that directly. But with React creates a virtual DOM, and that virtual DOM is what we manipulate, and it results in the actual DOM being updated, and that's what we serve via HTML. And so this is another example of how that works. And so there are 3 main components in React that you should know, okay? So the first one, to be a little meta, components. The first one is called components. The first component is called a component. And these are self-sustaining, independent micro-entities that describe a part of the API. And so this is an example of a component. Now, these components can be anything. These components could be a button, they could be a Stripe login, they could be anything. But the idea is that we are coupling the data processing and the HTML rendering together into this and state. So notice how you're setting these values here directly inside of this JSX code. So there's a lot of JSX happening right on the client side. So you might be thinking, well, okay, so this component is that structure, right, for serving users. The button is that component, and it's any type of button can be a component. Any type of list can be a component. And we write these in JSX, as you see here. And there are different ways to then send data to that component, right? Whether it's from the database, whether it's from the user. How do we do that? Well, there are two ways. The first is to use what are called props. And the React philosophy is that props should be immutable and top down. So this is an example of a prop. This button has a prop, and the prop is 21. So that's one way. And we say that prop is fed to the component, and that renders the DOM. Another way is to give state directly to the component, and that is an object that is owned by the component where it is declared. And so a user could click on a button, they could sign up, they could open a menu. All of these things are added to the state. Those are the two things we can feed to our component, either a prop or a state. And the idea is that HTML and JavaScript become this language called JSX, and that's what's served on the front end, and that is React. And so Node is happening on the back end, and React is happening on the front end. So what else are we going to do on the front end? Well, we need some kind of middleware, and middleware is in the middle of front and back end. Routing is a perfect example. Now, we could use all sorts of different routing techniques. Basically, how do we route data throughout our app between different pages, like the index page and the about page and the sign up and the dashboard and the upload page. And so the universal router is a JavaScript framework that is very modular. It's what that app used. And what it does is it allows us to define routes just like this. We say, here's our route, here's the path, and then do some action, and it's going to create a route at whatever path we say. Now, the action can be some HTML we want to embed. It could be, performing any kind of event, whatever it is, but that's a very simple idea, and we can define all of our routes in a single file. That's super clean. Now, what else do we want for the front end? It's using this tool called Material UI. Now, Material UI, these are a collection of different React components that Google uses internally, and we can basically use them as, building blocks like Legos. There are a bunch of pretty buttons and little widgets that we can use, just put together, and they're React compatible, and we'll just go ahead and drop them into our app. Now, one more explanation before we start building, and that is database design, right? We've designed our front end, we've designed our software, we've ideated, now it's time for database design. So PostgreSQL is an ACID database. What does that mean? It has atomicity, consistency, isolation, and durability. And this is a good thing. What that means is that our database is not prone to power failures and all sorts of other errors. Postgres is ACID compliant out of the box, whereas MySQL needs to have a specific data store to get ACID compliance. And it's got great user security, amazing schema, system, etc. And we can look at an analysis of MySQL versus Postgres, and it seems like overall Postgres is a better database to use. And this is an example of the Postgres QL architecture. The idea is that a client will make a request to it, the database lives there, that little cylinder, and then all of these little backend processes like collecting statistics and making logs of what has happened, what has occurred, archiving different data points. All of these services Postgres handles for us, which is awesome. And what else do we want for Postgres? Well, we're going to use this tool called Connects. Now, what Connects does is it creates an API to actually access that database, right? It lets us create an API just like this that lets us then access that database. It's got a nice little landing page right here as well. That's going to let us access the database. Then we have GraphQL. GraphQL is the actual query language that we'll use to communicate with the database. So Connects will create that high-level API, and it's going to be like an HTTP API. However, it compiles down to GraphQL queries like this for, say, a user ID with all of that user's attributes. And then there's Relay. Don't worry, I know it's a lot. Don't worry, I'll wrap it up very nicely. And then there's Relay. And so what Relay does, it lets different components on the back end, like GraphQL and Connects, share share data. So it's a way to share data between these different components. It's actually a smaller component. And lastly, there's Firebase. And what Firebase will allow us to do is to store our database in the cloud. And this is a Google service. So what we can do is we can use Firebase to store our database, and it's going to replicate our PostgreSQL database that we have locally in the cloud, and then we can upload it to Google Cloud, and it's going to connect because it's a Google service. Firebase database, Google Cloud is where it lives, or we could just host it on Firebase, whatever you want. It doesn't really matter. So those are the components. So you might be thinking, well, that's a lot of different components, like it's too much to wrap my head around. Well, just know this, that there are only 4 main tools that you need to know, and everything else is just a helper tool, right? React for the front end. What does the front end look like of what the user sees? React. Node, which is the backend. Postgres, which is the database. And lastly, TensorFlow, which is the AI layer that's what's being served to users on top of this, the electricity we're trying to serve people with, right? So let's get to building, shall we? So we've talked about all of that. Now it's time to build. So what do we want to build? What order are we going to build everything in? It's a great question, right? And this is our step 7, software engineering, before we do machine learning. So we're going to first integrate Stripe payments, then CSV upload, and then we're going to save both of those actions to the database for a specific user. So a user has made a payment and they have uploaded their file, and we can store that as an ID for that CSV, and it points to the actual CSV. So when it comes to Stripe payments, I was looking for a really good tool for this, and unfortunately, it was hard to find a Stripe tool that worked well. And so I found this tool called React Stripe Checkout. And what it allows you to do is it allows us to use Stripe Checkout as a component. So notice this is a component in React. So that's what we're going to do. So let's go into this code and see what it looks like. So I'll open this code up and we'll go down here. So there's actually quite a lot of files in this code, but luckily this README has a nice little description of every single folder and file, so we can see what each of these files are. So if we go into this, we'll see that probably the most important file is inside of source, that's our app, and then inside of server, that's our server, we have index.js. And index.js is going to load our API keys. It's then going to start our Node.js app, and it's going to initialize the connection to Firebase. All great stuff. They've created production and testing environments for us already. Great. And that's awesome. What Passport does is it allows us to automatically connect to a bunch of services like Google and Facebook if we wanted, and a bunch of different services, which is great. Now, if we look in, let's see what we've got here. Let's go to news.js. Great. So in news.js, if we go to our app, we can click on news. So notice how I renamed it to upload for my own app. This is a good basic page right here that we can then manipulate and change so that it has that Stripe functionality. So how will we do that? Well, let me go back to the code that I wrote from earlier, and I'm going to type it in here. So it's import Stripe checkout, and then we're going to paste that in right here. Right here. Notice, by the way, when I add this Stripe import right here to this app, it's going to then automatically break because it's got fast reloading, which is awesome. It reloads in real time, which is really cool. Okay, so let's check out what this news.js file looks like, because this is a template for the rest of the code as well. It's going to start off with a bunch of styles. These are CSS styles, but in the React way of doing things. We create it as a constant that we then call later on in the code. Remember, CSS, JS, and HTML all in the same file. And then we have a bunch of functions like the news function that has a bunch of event listeners, like if a dialog has opened, perform these actions. And when it returns, so for each of these functions, when we return, that is where the JSX code goes in. So notice it looks very similar to HTML. It kind of looks like JavaScript as well. This is JSX. And notice that this is the main difference here, is the use of the word class name instead of class. Right, so class would be JavaScript, class name is JSX. So inside of this render code, notice that this text is exactly what we saw right here, the latest news from the React.js community. And what that means is that if we modify this the latest, this modifies as well, right? The latest. So this is where we want to put our Stripe button. And so we can put that button here by, first of all, installing that Stripe checkout module. We'll paste it right here. And then we're going to add that button, that Stripe button, right there. Okay, so it goes right there. And now we have that button. It's a nice little component in the React sense. And it has a test. We can change the attributes of that component. We can do whatever we want. We could say lol, we can make it say, not test2. We can have it say not charge 100. It could charge only 10. Whatever we want, it's going to do that. And so that's the Stripe part. We integrated payments. What else? We want to integrate CSV uploads. So how do we integrate CSV uploads? Well, I had this little container called CSV Reader right under it. And so this is another Stripe component that I added to the code. And the way I did this is I searched for React CSV upload. And there's one good as day right there. It's called React CSV Reader. And we do yarn add to add that. And once we do yarn add, it's going to add it to our system. Just like that. And so once it's done downloading, we could use it. And here's the usage. So just inside of that render function, here it is. Here's the component, the CSV Reader component. We just go back to our code and we copy and paste it, and there's our CSV Reader. Now what this reader will allow us to do is then upload our file, which we'll say is going to be, whatever, the client sheet.csv, whatever we want to call it. And then once that's done, we've added that part. Now we want to save both of those things to the database. And the user's name is right here, right? We already know who the user is. And so we just want to add that to the query whenever we save that. So we'll say Stripe and we'll say the CSV file, both of which we're going to create schemas for in the database, and that's going to save that. And that's it for the software engineering part. Now we're going to do the machine learning part, and that's the fun part, right? So we created the index page, we created the upload page. Now we want to do machine learning on that last results page. We want to do machine learning on that data, and then we want to visualize that data for the user. We've already done payments, we've already authenticated the user, they've already paid. It's time to do machine learning. Now I'm going to use Tensorflow.js to do this, and I have a great video on how that works. Just YouTube Tensorflow.js Siraj. It'll be the first link. And to visualize that data, I'm going to use a very popular visualization library called d3.js. Amazing library, definitely check it out. Okay, so let's do both of those things. Now, when it comes to Tensorflow.js, there are a bunch of really great tutorials that they have on their website. They have a bunch of models, they have a bunch of demos. Great stuff. It's a nice little setup page here, and it's got this nice little yarn add as well, which we'll do. We'll do yarn add, and that's going to add Tensorflow.js to our product, and then we can import that just as we would any other dependency, and then use that in our app. Okay, so I'm going to import that right here. So import TensorFlow from TensorFlow.js. Whatever the name of that library was. Oh, this is what it was called. Without that. And then once I've imported it, I'm going to start building. We have that data. Now, how are we going to actually use that data? We have that data. I want to show you how I did this. What I did was, so for that CSV reader, what it does is it creates this, it's got this event listener called onFileLoaded, and we can name it whatever we want. So right here, I've called it handle force. And so what happens is whenever that file is uploaded, it's called handle force, this fires right here. So if we do console.log, this will fire. And then inside of that, what I did was I said, okay, the first thing we want to do is data preprocessing. So we take that data and then we say, we're going to strip it of all those undefined empty data points, right? All the empty rows and all the empty data points. And once we've stripped it, we've cleaned it, then we're going to vectorize it. Now, tf.js has this great vectorization function called tf.data.array, which turns an array into a tensor that's ready for processing. Now, once we have that, we're going to, so in this example, I generated some dummy data just to see if it would work. We're going to build this very simple neural network, two-layer network, for testing purposes. And when we have that, we're going to compile it with standard stochastic gradient descent. If you want to know how that works, Google gradient descent Siraj, first link. And then we're going to fit the model on that data and the labels that we got from splitting the data into training and testing data. And once we have that, we're going to print that out to the console. So if we go back to our code, we're going to open up console. And inside of console, we're going to inspect what's happening here. We can see what is happening here. So I'll go ahead and upload, some code here, or I'll upload my CSV. And now, perfect. So because I had those console.log statements, we can see everything that it's uploaded. And I've uploaded all of my clients. So all of my clients, it's an array of arrays. It's a multi-dimensional array. It's a nested array. So the first array is the names of all of those features. And then the next array is the name of all of those rows and all of those clients. So for each feature, client company, there's a bunch of clients. But the thing about arrays are, they're not tensors. They're not ready for Tensorflow.js. So that's why we use that function called, what was it called? That function was called tf.data.array to turn it into a dataset object, which TensorFlow can then use. And then once we have that TensorFlow dataset object, we're going to start training our model. Now, this is a log of the model being trained right here. We can see it right there, And that was just one neural network. Now we can continually add other networks, right? Just one by one by one. And I also noticed a sloppy way that I just put that model into the, and so this is the other model, by the way, that I just commented out, but we can, re-add it in if we want to. But the point is that I took these models and I built them from scratch. I trained them on the data set and I put them directly inside of the render function. But what would be cleaner is if we created a separate JavaScript file and then called that function as, say, train model directly in that code. So it would just look cleaner. But hey, fastest method to prototype, right? Now, I also, one thing we could do, and to be honest, I still haven't implemented it yet, but it's super, super easy to do, is we would pull from an API to create extra features for our clients. And what this would do is it would give our model more data to train with. Now, ClearBit, my friend, Alex made this a couple years ago. ClearBit is a data API. So you give it some email or something like that, and it's gonna give you a bunch of data points about that person from across the web. And what we can do, like their social media links and their browsing history, things like that, we can add that data to our existing CSV file, and then we can train our model on all of those features. So the more data, the better, at least for neural networks, right? And so that is something we can do. So we just go to ClearBit API, React, and probably ClearBit has a React component. If not, we'll go to the ClearBit JavaScript API, and there's an API reference. Oh, so great, NPM right there, perfect. And then we can just say we want to use our prospector API based on each of those. So it'd be a for loop for each of those emails. Make that request, asynchronously. Thank you, Node.js, and then fill in that CSV with that data. Or we could do it in memory, and we can make sure that those tensors then have that data as well, or that multidimensional array. Okay, so once we have that, right, we've done that last part, which was machine learning. We've done that. Now we want to display that data to the user, right? And when we think about binary classification, what it's doing is it's trying to say hot dog, not hot dog, right? Lead, not lead. Likely lead, not likely lead. And when it makes that classification, it turns out that it's on a scale of 0 to 100 because it could be 87% likely that it's a 1 versus 13% that it's a 0. And we can take that number, that 87%, and that is our automatic lead score. That number is our lead score. And we then append the existing CSV file with those lead scores, and we return that to the user. So on the last page, the page that shows the results, what I did was I used d3.js to build out different data visualizations that the user can see, and we pull that from the CSV file. And so with the CSV file, we can then say, get CSV, and then take that data and display it for the user. Now, this is data visualization stuff. There's actually, there's quite a lot, but none of it's hard. Like comparatively to React or any of those other components that we were just building, it's much simpler. But the idea is that we feed that data to this visualization library, and then it's going to show that to the user. By the way, when we train, we want to make sure that's happening asynchronously. So we can make that happen asynchronously while we show this animated icon, thanks to d3.js, of loading that to show the user that it's training. And while the user is seeing this, they're patiently waiting. And then eventually it's going to display, the result, and then we can download that data very easily with a simple DOM element, that button, and then it downloads the CSV directly from our database. So there's more, right? I mean, I didn't go into the details of, the schema of the database. Let me quickly do that. Migrations, admin, index. See, these are the different elements of the database. We have a list of stories, we have a list of users, and that's really it, because it's a boilerplate, but we can create more if we wanted to. And that's where GraphQL comes in. And in the server, we have these little helper functions for finding users by their credentials. And there's a bunch of other configurations we could use if we wanted to. But the point is that this app works. You can find it in the video description, my work so far. And I hope you found it useful. And remember when I mentioned universal routers? This is that page, the router.js file. It shows the universal routers that you can see right here. And it's using GraphQL to get those. It's using promises as well, which is kind of like callbacks. There's so much to explain in this video. There's quite a lot. But the point is that I mentioned the tools that I used, how I built this, the ideation process, and I hope all of it is very useful to you. Overall, I hope this video was educational and inspirational for you, and I hope that it gets you excited to start your own startup, to build, to serve people with AI, and make a profitable business out of it. Please subscribe for more programming videos, and for now, I gotta fix some bugs. So, thanks for watching.